All right, I am going to go over with you the unit circle. Maybe you weren't in class when we covered this. Maybe you just want another quick refresher on the unit circle. So a couple of things that we're going to do. Up here in the corner, what I'm going to write down is the following. Sine of theta is y. Cosine of theta equals x. Tan of theta is going to equal y over x, which is the same thing as sine of theta over cosine theta. Now from class, a couple things hopefully we remember. This is our quadrant 1. All trig functions are positive in quadrant 1. Here we have quadrant 2. Sine and cosecant are quadrant 2. Sine. Down here, we have quadrant 3, which is tangent and cotangent. Tangent quadrant is positive in quadrant 3. Down here, quadrant 4, cosine and secant are positive in quadrant 4, cosine. So the reason I did that, all students take calculus. That tells you what's positive in each quadrant, or Al Snyder teaches children. So it tells you what's positive in each one of the quadrants. Now what I'm going to do is go on these increments of 90 degrees. There's 0 degrees, which is 0 pi. Now one thing we need to remember, the radius on a unit circle is always 1. So if this is always 1, that means a cosine of 0 is 1, and the sine of 0 is 0. Let's go up here. 90 degrees is a radian, that's pi over 2. Starting at the origin, I don't go left and right on all, so the cosine of 90 degrees or pi over 2 is 0, and the sine is 1, because you go up 1, the radius is 1. Down here we have 180 degrees, which is pi. Negative 1, 0, so the cosine of 180 or pi is negative 1, sine is 0. I'll come down here, another 90 degrees. 270, which is 3 pi over 2. This is 0, comma, negative 1. Now before I go on, before I talk about anything else, real quick, what I'm going to be referring to going forward are two triangles. Our 30, 60, 90 triangle. Here are the sides for that. Now remember, this can be root 3x, 1x, 2x. And everything's based off of that side right there. Then we also have our 45, 45, 90 triangle. Those two angles are 45. This is 1, 1, and root 2. Or 1x, 1x, root 2x. However you want to look at it. Now hopefully we remember sine of theta is going to be equal to opposite over hypotenuse. Cosine of theta is going to be equal to the adjacent over hypotenuse. Tan of theta is opposite over adjacent. Now over here we're going to have cosecant of theta is the reciprocal of sine. Hypotenuse over opposite. Secant of theta is going to be hypotenuse over adjacent. Tan of theta is going to be equal to adjacent over opposite. Now let's take a look at, we're going to be using these two triangles when we fill this in, okay? So I want you to think about this triangle right here. It's a right triangle. This is my angle, 30 degrees, which is pi over 6. So I need to reference this triangle down here when I fill in the sine and cosine. Back up real quick. Remember, that's cosine and this is sine. The cosine of 30 degrees is root 3 over 2, adjacent over hypotenuse. The sine of 30 degrees is 1/2, opposite over hypotenuse. Tangent is 1. Now what I'm going to do is come over to this triangle. This is 30 degrees. So if this is 30 degrees, that means this angle here is 150. That's 5 pi over 6. 30 degrees, cosine of 30 degrees is root 3 over 2. In the second quadrant, cosine is negative, so I need to put a negative sign out front. Sine of 30 degrees is 1/2. Now I'm going to do the same thing down here in the third quadrant. These are all reflections, right? This is 30 degrees, so again I use this triangle down here. 210, which is 7 pi over 6. Cosine of 7 pi over 6 is root 3 over 2. Sine of 7 pi over 6 is negative 1/2. Notice we're using 30 degrees right now. Only thing that changes is the sign up front depending on what quadrant you're in. Here's 30 degrees. I reflected over the x-axis, which means the x stays the same, root 3 over 2, and the y changes. By the way, this is 330 degrees, which is 11 pi over 6. Oh, it just occurred to me I forgot to fill something in. Let's go back up here. 360 degrees or 2 pi. Now we are going to go to this angle. This, again, is a right triangle. Looking at this triangle, that is 45 degrees. As a radian, that's pi over 4. So now I'm going to use this triangle. Cosine of pi over 4, 45 degrees, is 1 over root 2, because adjacent over hypotenuse. When you rationalize that, you get root 2 over 2. Sine, opposite over hypotenuse. Same thing, root 2 over 2. Which means tangent is going to be 1. Now we're going to take this point and reflect it over the y-axis, which tells me the x-coordinate has to change. So this is 135 degrees. So radian, that's 3 pi over 4. X-coordinate has to change because I'm reflecting it this way. Y stays the same. Tangent's negative 1. Now when I come down here, I'm reflecting this point over the x-axis. This becomes 225 degrees, which is 5 pi over 4. If I reflect over the x-axis, the x-coordinate stays the same. The y-coordinate changes. Sine divided by cosine is tangent. That's 1. Now I'm going to take this point and reflect it over the x-axis. 315 degrees, or 7 pi over 4. Let's draw my triangle. When I reflect over the x-axis, the x-coordinate stays the same. the y-coordinate changes. It's just another way to look at it. We're almost done. Let's take a look at this angle. For this triangle here, that's 60-degree angle, which is pi over 3. Cosine of 60 degrees is 1/2. Sine is root 3 over 2. Take this point and reflect it over. And when I reflect that over, the x-coordinate changes, y-coordinate stays the same. Oh, I'm sorry, I forgot to put that in. This is going to be root 3, which means in the second quadrant, it's negative root 3. Reflect this point over the x-axis. This is, oh shoot, didn't put it in. 120 or 2 pi over 3. Reflect this point over the x-axis. 240. 4 pi over 3. Negative 1/2, negative root 3 over 2, and this is root 3. That isn't right. I'm going to finish this up. (300 or 5 pi over 3. I'm reflecting this point over the x-axis. Cosine stays the same. Sine is the opposite. Cosine in this case is negative root 3. I've got to go back and make a correction. This tangent angle is root 3 over 3. Not 1 is root 3 over 3, which makes this negative root 3 over 3. This is positive root 3 over 3. So that's your unit circle in a nutshell. Now, something else I want to point out to you is the following. If I start here, notice all my denominators, as far as sine and cosine, are always 2. Yeah, they're always 2. This goes 3, 2, 1, 3, 2, 1, starting the x-axis. 3, 2, 1, 3, 2, 1. That's root 2 right there. X-axis, negative, or excuse me, 3, 2, 1, 3, 2, 1. That's the way it's always going to work. 3, 2, 1, 3, 2, 1. All you have to do is just count up to 3. All right, let me know if you have any questions on the unit circle.